through the metric system. And another name for it is the System International, or the SI system. It's commonly referred to the SI system. And as you see here, I have a gas tank, and the price on it you might think is quite cheap, $1.66, 209, 213, and you say, wow, that's really cheap gas. Well, you might also notice this name at the bottom, and that is not an American. This is not an American gas station. And this is not per gallon. This price is per liter. A liter is the unit of volume in the metric system. We tend to use quarts and gallons. Well, a liter is more or less comparative to a quart. So the price of this gas is actually much more expensive than here in the U.S. It might be as much as 2 to 4 times as expensive. I think right now in Turkey, the price of gas is about $9 or $10 a gallon. Now, I put this picture on here to emphasize the fact that the metric system, one of the advantages of it is that it is international, as the System International says. There's only a couple countries that do not use the metric system. There are prefixes in the metric system. The metric system, the other advantage is that it's all based on 10. So you can go from zepto to atto by dividing by a power of 10. You can go from mega to exa by multiplying by several powers of 10. And that's the advantage of the metric system. It makes it very easy to convert. May not be so easy for you because you didn't grow up with it, but the more you use it, you'll see that it does have its advantages in that way. Now, you don't have to memorize all these metric prefixes. We'll go through them, but I do want to look at this chart a little bit, and it's kind of interesting. Notice there are some capital letters for symbols, and then there's some lowercase letters for symbols. And it's important that you use whether capital or lowercase, because if you used a capital M, that would mean mega. That would mean 1,000,000 times larger. Let's say a megameter, 1,000,000 meters. Whereas if you use the lowercase m, that's a millimeter. That's 1,000 times smaller than a meter. So you're talking about a big difference in size there. So make sure you use your symbols correctly. Okay, this would be really what you're going to multiply your base unit by, these numbers here, and often we tend to do it in scientific notation because it's a lot easier. So now let's look at the prefixes you need to know. The prefixes you need to know are kilo, which means 1,000 times larger. Deci, 10 times smaller. It's 1/10. Centi, 1/100th. Milli, 1,000ths. Micro, 1,000,000ths, or 10 to the -6. And nano is a billion, 10 to the -9. Something to keep in mind is if the prefix is larger than the basic unit, you multiply by whatever factor of 10. So mega is 1,000,000, 10 to the 6, you multiply times your basic unit times 10 to the 6. Whereas if you're doing milli, it's smaller, the prefix is smaller, then you would divide by that factor of 10. So you would say a meter divided by 1,000. Milli means 1/1000th. You're actually multiplying by a fraction, multiplying by 1 over 1,000, which is the same as dividing by that factor of 10. So these are the prefixes you should be familiar with and know more or less off the top of your head. We're going to look at 3 basic units of the metric system. There are 7, but we're going to only look at 3 because these are the most common ones. We'll be dealing with some of the others we'll pick up later. Mass, which is the amount of matter, okay, how much stuff you have. We're going to look at volume, which is the amount of space, and we're going to look at meter, which is the unit of length. Okay. Now, mass, the amount of matter, the SI system, the standard is the kilogram, and this standard is actually held in Sevier, France, and it's a gold kilogram, and they do all kinds of, they don't disrupt it, but it's held under a vacuum under constant pressure, temperature, humidity, and they've actually found that it's been losing a little bit of mass over the years. It's just a very, very small fraction, but it has some people excited. But kilogram is about the mass of a can of soup, if you look at a can of soup, and a big can of soup. So we don't use a kilogram a whole lot. We're dealing with smaller amounts of matter, so we tend to use the gram, which the symbol is G. Okay, mass versus weight. On Earth, we tend to use the terms mass and weight interchangeably. And that's because on Earth, we all have the same pull of gravity, more or less. And so a lot of times I'll say you want to weigh out something when I really mean you want to find the mass of it. Okay. And we use scales. We use the electronic balances generally to find your mass. Well, but mass and weight, you should understand that they are two different things. Mass is the amount of matter. Weight is the pull of gravity. So here I have this odd looking person standing on Earth, and he has a mass of 60 kilograms. That's how much stuff he has in him. But his weight on Earth is 132 pounds. Well, this guy goes to the moon. His mass is still 60 kilograms. He hasn't lost any of the stuff that makes him up, but he has lost a lot of weight, like 110 pounds. Well, why is that? That's because the pull of gravity on the moon is so much smaller than the pull of gravity on him when he's on Earth. So weight has to do with that pull of gravity. Okay, so weight is a measure of gravity's pull on an object, and mass is just the amount of matter. It is not affected by gravity. Now, the basic unit of length in the metric system is the meter, and this is a distance unit. Okay, length measures distance between 2 points. And they used to have an official meter stick and all that, but now they've gone to a more general, where more countries and people can just make their standard meters, because it's based on the distance that light travels in a fraction of a second. What is that fraction of a second? It's right here. Here is the fraction of a second. So you can see in that very short amount of time, how far light travels is defined as a meter. In English units, it's about 39 inches, a little over a yard. Another common unit that we use is a kilometer. And a kilometer is, kilo means 1,000 times, it's larger. So you multiply your meter by 1,000. So 1,000 meters, and it's about 0.6 miles. And then a centimeter we'll use quite frequently, and a centimeter is smaller than a meter. It's centi 1/100, so you divide by 100. And that's about the width of your fingernail, if you have an average fingernail. And a millimeter, you would divide by 1,000. It's 1,000 times smaller than a meter, and a millimeter is about the width of a dime, just to kind of give you an idea. The last unit we're going to look at is volume units, and volume is the amount of space something occupies. A lot of students confuse mass and volume. Mass is the stuff you have. Volume is the space that you occupy or an object occupies. So the amount of space an object occupies. The SI unit, standard unit, is the meter cubed. Well, what's a meter cubed? It would be like if you had a box, like I have here, and it's a length of 1 meter, a width of 1 meter, and a height of 1 meter. Then the area would be 1 meter cubed. Now you notice that I got the volume by multiplying length units. Okay, that is a derived unit. Volume is what we call a derived unit because it comes from other units. A meter cubed is rather large. If you were to convert that to centimeters cubed, that'd be 1,000,000 centimeters cubed. And you go, well, I thought there's 100 centimeters in a meter. There is. But if when you're doing area, you're multiplying. So if you had 100 times 100 times 100, that's 1,000,000 centimeters cubed. That's kind of large. So we tend to use a smaller unit, the centimeter cubed. And that would be if you had a cube, as I have here, of 1 centimeter by 1 centimeter by 1 centimeter. That'd be a centimeter cubed, and we call that milliliter. Okay, and we're pretty familiar with milliliters. We know we measure milliliters in graduated cylinders. Okay, and another common volume unit is the liter, and a liter is about 1,000 milliliters, and that's in that initial picture is what they were measuring or pricing the gas at per liter.